So with this video we are going to understand the conservation of energy principle and principle, and this is going to be a base for a lot of different concepts and a lot of different topics, and it is going to be helpful to solve a lot of problems. So we'll every time start with conservation of energy principle for solving problems regarding heat transfer, or to derive some equations, derive some concepts, derive some formulas, or this same things is also applicable in fluid mechanics or solids where these things are involved. Mass transfer is involved, or in solids of mechanics of solid when we have elastic energy, plastic energy involved. So this energy conservation of energy principle is very basic law. So there is one first thing which comes, there should be some form where the energy is generated. So one is generation and the second is use or transfer to some other body. That means for the interest, the body of our interest, it is losing heat. So we will only care about a control volume. We will not care about what's happening outside the control volume. We will only say we have a control volume, which is this, and then we have a surrounding. So everything other than control volume is included in surrounding. So these two things makes universe for us. This is the area of our interest or volume of our interest. This is also in our interest, but everything which is not in a control volume is combined with surrounding. So we have a concept of control volume, and then we also had a concept of control mass, which we would have studied in fluid mechanics. So both of these concepts of fluid control volume and control mass are covered with fluid mechanics. So over here, a control volume basically means if we have some body, it may have solid, it may have liquid, anything, and let's say this is there, and we can make a control volume which is completely capturing that solid. So this is our body, or we can make another control volume which is like this, or we can exactly make a control volume which is at the boundary of this. So it depends, we have the complete freedom of choosing control volume, but for any given control volume, this thing is defined that whatever we have energy, so this E is the symbol for energy, capital E. Whatever energy we have stored in control volume, so CV I am writing for control volume. I would also write volume as VOL dot, right? So whatever energy which is stored in control volume, the total energy, let's write also total energy, means whatever it had generated, energy generated minus energy out plus energy in. Do you understand? Whatever is coming in, whatever is going out is subtracted, and whatever is generated is also added. So this all subtraction and addition remains what is stored inside the control volume. Okay. And now what can be generated? So let's define what all things can lead to generation of. So generation of chemical energy. So one could be a chemical reaction. So these all things, whatever I am listing right now, would be helpful when you are solving problems. There it may be defined as a chemical reaction is happening. So it can be exothermic or endothermic. Exothermic means it is generating energy. Endothermic means it is using energy. It is taking heat from the surrounding for the reaction to happen. Exothermic means as the reaction is happening, it is losing heat to the surrounding. It is giving away heat to the surrounding. Second could be nuclear reaction. Third could be an electricity involvement. Electrical wires or electrical equipments. This is of prime importance to us while solving problems because if current is given, resistance is given, we can find out joule heating. That is of importance, joule heating. So we have known this thing. The power is I square R, or the energy is I square R. I don't remember it, but energy. So that is the I square R term is useful for us. That is involved over here. That is called as joule heating. This is the term, technical term, which is involved. Okay. So we'll stop over here. In the next video, we'll start with the main goal of us, which is heat. So thank you.